Welcome back to the Deep Dive. Today we are taking on a true heavyweight, a genuine monster of the Second World War skies.
We are. We're talking about the Republic P-47 Thunderbolt.
And this isn't just a story about an aircraft. It's really a story about how an underdog, something that was initially just laughed at, completely changed the game.
It's the ultimate counterintuitive success story. You've got this machine that, everyone dismissed at first. Even its own pilots were skeptical.
Right.
And yet it goes on to become the most successful U.S. fighter bomber of the war. So our mission for this deep dive is to figure out how that happened.
To trace that journey.
Exactly. To peel back the layers of, the engineering choices and the tactical changes that turned this thing they call the flying milk bottle into an absolute apex predator.
A predator that terrified people in the air and maybe even more so on the ground.
Oh, definitely.
And to really get a sense of that transformation, you have to start at the beginning. You have to start with that ridicule.
You do. The story of the Thunderbolt's reputation, or its lack of one, really kicks off on a crisp morning, April 8th, 1943.
So this is its first major combat outing over Europe.
Its first big test, high above occupied France, and you have to picture the scene. The skies over Europe at this point are, they're the domain of these sleek, highly tuned fighters.
The icons, right? The Spitfire, the Messerschmitt.
Yeah, you've got the beautiful elliptical wings of the Spitfire, the lean, lethal profile of the Bf-109, and then the compact brutality of the Focke-Wulf 190. They're like flying scalpels.
And then this thing shims up.
And then the first wave of P-47s arrive.
We actually have a specific account of this moment, don't we? From a German ace.
We do. Oberleutnant Rolf Hermeken.
Yeah.
A very experienced, very successful pilot flying his Focke-Wulf 190. And as these enormous, almost bulbous shapes lumber into view, he knows they're the new American fighters he's heard about.
And his reaction is not one of fear.
Not at all. It's immediate, and it's just pure contempt. He gets on the radio to his wingman, and this quote has become legendary because it just perfectly captures that moment.
What did he say?
He was genuinely laughing. He transmits, "The armies have sent us flying milk bottles."
Flying milk bottles. Wow. That's his everything.
It does. I mean, what they saw was this grotesque 7-ton beast. It had this huge barrel-like fuselage, an engine that just looked impossibly large.
Bolted onto these wings that seemed way too small and thick for a plane that size. It just looked wrong.
It defined everything they understood about what a fighter should be. Their entire doctrine was built around lightweight, agile dogfighters.
Yeah.
Tight turns, high rate of climb.
And the Thunderbolt was none of those things.
None of them. To them, it looked clumsy, it looked slow, and maybe most importantly, it looked like a huge, fat target just waiting to be shot down.
But that first impression, that absolute confidence they had.
It completely missed the point. It overlooked the stubborn, hidden brilliance of the philosophy that created it in the first place.
Okay, so let's unpack that. This behemoth. When you see a P-47 on the ground next to a Spitfire, the difference is just staggering.
It's night and day. The label Beast of Burden is perfect. It's just sheer scale. We're talking about an aircraft that weighed almost twice as much as a fully loaded Spitfire or Messerschmitt.
And that weight, that size, it wasn't an accident. It was a direct consequence of the design goals.
Absolutely. It all goes back to the chief designer, Alexander Kartveli.
Right. And Kartveli is such a fascinating figure because he seemed completely uninterested in making a beautiful airplane.
He wasn't building a sports car. He was building an armored truck. He intentionally broke all the conventional rules of fighter design at the time.
So what was his core idea? What was he aiming for, if not agility?
Survivability and energy. His philosophy was that in the vast skies over Germany, a turning fight was less important than being able to fly high, fly fast, and bring your pilot home.
Even if the plane was riddled with holes.
Especially if it was riddled with holes. He knew what kind of war this was going to be. He was building something for a long-range escort mission deep into enemy territory. He wasn't building a dancer. He was building a flying engine block.
He even had a nickname for it himself, didn't he?
He did. He admitted it would be a dinosaur, but he insisted it would have, and this is a great phrase, good proportions for its job.
And that job was all about the engine. The entire aircraft is basically designed around one component.
One single component. The Pratt & Whitney R2800 double wasp engine.
So tell us about this engine. Why was it so important, and why did it create this milk bottle shape?
The R2800 was a game changer. It was a twin-row, 18-cylinder radial engine, a beast. Early versions were pushing out around 2,000 horsepower.
Which is a huge number for the time.
A massive number. But that power came from its size. Unlike the sleek, liquid-cooled inline engines that the British and Germans loved, like the Merlin or the DV605.
Which gave their planes that narrow, shark-like profile.
Exactly. The R-2800 was air-cooled, which meant it was big and round. It was a huge, heavy chunk of metal up front. But that was also a strength. It was inherently tougher.
So that's step one. You commit to the biggest, toughest, most powerful engine you can find, even if it messes up your aerodynamics.
Right. And then comes step two, which is the real key to the P-47 shape. How do you make that engine work at 30,000 feet?
Where the air is incredibly thin.
So thin that a normal engine would be gasping for breath, producing a fraction of its power. You need to force feed it compressed air.
And that means you need a supercharger.
Not just a supercharger. For this kind of high-altitude performance, you need a turbo-supercharger. And this is the single detail that explains everything about the Thunderbolt's grotesque shape.
Okay, so break that down for us. Why couldn't they just bolt it on next to the engine like other planes did? Why the weird, complicated layout?
Well, it comes down to physics, really. Thermodynamics.
Yeah.
The R-2800 needed a huge volume of compressed air, which meant the turbo unit itself was enormous. We're talking about something the size of a small garbage can.
Wow.
And this unit gets incredibly hot because it's driven by the engine's exhaust gases. You can't just stick that massive, red-hot piece of machinery in a cramped engine bay.
So Kurt Valley had to find somewhere else to put it.
He put it in the only place that made sense logistically. All the way in the back of the fuselage, down by the tail wheel.
The back of the plane. But the engine's in the front.
Exactly. And that's why the fuselage is so deep and round. You need these massive ducts, these huge pipes, running the entire length of the aircraft.
Wait, so you have pipes taking hot exhaust gas from the engine all the way to the tail?
To spin the turbine. And then you have another set of enormous pipes to bring the now highly compressed, very hot air all the way back forward to the engine.
And it has to be cooled down before it goes into the cylinders.
Right, so you need intercoolers as well. The entire belly of the P-47, from nose to tail, is essentially a complex, high-pressure plumbing system.
So it looks fat because it's just full of pipes.
It's a flying plumbing gunner designed for one purpose, to allow that massive engine to breathe at high altitude. That single engineering choice dictated everything else.
And it forced the compromise on maneuverability.
It had to. You can't have a 7-ton aircraft full of ductwork and expect it to turn like a Spitfire.
And in those early days, in the skies over Europe, that compromise looked like a fatal flaw.
It really did. The American pilots, they were trained on lighter planes. They tried to get into these classic turning fights with Focke-Wulfs and Messerschmitts.
It was a disaster.
A complete disaster. The Germans would just turn inside them, get on their tail, and open up. The P-47 was sluggish in the turn, and its climb rate initially wasn't great either.
And that's where the Germans came up with their own nickname for it.
That's right. They started calling it Indiana.
Which means?
Basically fat targets. They saw these big, slow-turning planes and thought it was going to be easy. They saw the vulnerability.
But they were missing the flip side of that coin.
They were completely missing the hidden strengths that Kartveli had built into his intentional dinosaur. Strengths that were about to give them a very nasty surprise.
So the Germans are feeling pretty confident. They've got this new American fighter pegged as a big, clumsy target. And Indiana. But then the combat reports start coming in and the numbers don't add up.
Right. There's this anomaly in the data that the Luftwaffe analysts just can't quite figure out at first.
What was it?
It was simple, but it was strategically huge. The P-47s were getting hit a lot, but they weren't falling out of the sky.
They were coming home?
They were coming home, sometimes barely, shot to absolute ribbons, but they were landing. A German pilot was used to seeing a fighter burst into flames or break apart after a good burst from his 20-millimeter cannons.
Especially on a liquid-cooled engine, right? One hit to the cooling system and you're done.
The fight's over. You've got minutes before the engine seizes. But the P-47s they just kept flying. They refused to play by the rules.
And that has to change the entire calculation for a German pilot. You're taught that a solid hit is a kill. But now you're hitting this thing, you see the flashes of impact.
And it just soaks it up. It keeps on going. It fundamentally undermines your confidence.
So why? Why was it so unbelievably tough?
A lot of it goes back to that R-2800 engine.
Yeah.
Being an air-cooled radial, it had no vulnerable liquid cooling system. No radiators, no fragile pipes full of glycol.
You could literally put holes in the cylinders and it might keep running.
Absolutely. You might lose a cylinder or two, the engine would run rough, but it would often keep producing enough power to get home. The engine itself was like a piece of armor plate at the front of the plane.
And the rest of the fuselage, that big empty-looking barrel.
That was another unintentional benefit of the turbo-supercharger design. Because the fuselage was so large to accommodate all that ducting, the critical systems inside, the control cables, the wiring, the fuel lines, were all spread out.
So a single burst of machine gun fire was less likely to take out multiple vital systems at once.
Exactly. A bullet might pass clean through 5 feet of fuselage and hit nothing but air and a non-critical piece of ductwork. The whole thing was just structurally overbuilt. The wing spars were massive to handle the diving stresses. It was, in every sense, a tank.
And there's one story, one specific incident that really cemented this reputation. It became legendary.
It did. The story of Lieutenant Robert S. Johnson in June of 1943. This is the moment where the Germans had to face, in the middle of a fight, the sheer physical impossibility of killing this airplane.
Set the scene for us. Johnson is in serious trouble.
He's in a disastrous situation. He's been ambushed over France by a very skilled Focke-Wulf pilot. His P-47 is already crippled.
And we're not talking about just a few bullet holes here.
No, we're talking catastrophic damage.
Yeah.
A cannon shell had already hit his canopy, fusing it shut. He's trapped in the cockpit.
Oh, wow.
His engine is sputtering, just barely holding together. And critically, his hydraulic lines are shot. The cockpit is filling with hydraulic fluid. It's all over his instruments, and he can barely move the controls.
By any normal standard, he should bail out. Or he should be dead.
He should have been a statistic.
Yeah.
But he's still flying. And the German pilot sees this crippled plane and moves in to finish the job.
Just a routine kill, he thinks.
A routine kill.
Yeah.
He comes in for a systematic, close-range execution. And he empties his entire supply of cannon ammunition into Johnson's plane.
His entire supply.
All of it. We're talking 20 millimeter, maybe 30 millimeter explosive shells. These are rounds designed to tear the wings off a B-17 bomber. He pumps every last one into this already wrecked Thunderbolt.
And Johnson's plane is still in the air.
It's still flying. It must have looked like Swiss cheese, but it was flying. The German pilot has just used up his best, most destructive ammunition, and nothing.
He must have been furious. And confused.
You can only imagine the frustration. So he switches to his secondary weapons, his machine guns, and he just keeps hammering the wreck, trying to find that one weak spot that will finally bring it down.
This goes on for minutes, just a relentless attack on a plane that refuses to die.
It does. And then you get to the most incredible part of the story, the moment of just pure, jaw-dropping disbelief.
He runs out of bullets.
He runs out of everything. Cannons, machine guns, the lot. He is literally out of ammunition. He has no choice but to break off the attack.
And what does he do?
He pulls his Focke-Wulf up alongside Johnson's battered smoking P-47, so close that Johnson can see the guy's face in the other cockpit.
He's looking at a ghost, a plane that should have disintegrated minutes ago?
He is looking at a machine that defies physics, that defies everything he knows about air combat. And the German pilot, in this moment of just sheer bewilderment, simply shakes his head.
And
he gives Johnson a salute, a sign of respect, not for the pilot, really, but for the impossible toughness of the machine he was flying. And then he peels away and heads for home, completely empty-handed.
wow. That story must have spread like wildfire.
It became the defining legend of the P-47. It cemented the idea that you were flying a fortress. And that gave the American pilots an incredible psychological edge.
Because you knew you could take a punch. A really big punch.
You knew you had a margin for error that no one else had. It bought you time. You could be bolder, you could take risks, because you knew your aircraft was designed from the ground up to survive. Kartvel's philosophy was completely vindicated.
Okay, so the pilots now know they're flying the toughest thing in the sky. It's a tank. But it's still, a clumsy tank in a turning fight.
Exactly. Being tough is great for survival, but you still have to shoot down the enemy. And they couldn't win by playing the Germans' game.
They couldn't outturn a Focke-Wulf, so they had to find a new game to play.
They had to completely change their thinking.
Yeah.
They had to stop thinking about the fight in 2 dimensions, the horizontal plane, and start thinking in 3 dimensions.
They had to start using the vertical.
Precisely. They had to leverage the P-47's actual strengths, that incredible engine, that robust airframe, and its single greatest asset, its weight.
Turning its biggest weakness into its biggest strength.
And that necessity gave birth to the tactic that would define the Thunderbolt. Boom and zoom.
It's such a great name. And it's a tactic that is rooted in just pure, brutal physics.
That's all it is. It's about energy management. In air combat, you're always trading 2 kinds of energy. Potential energy, which is your altitude, and kinetic energy, which is your speed.
And the P-47 was a master at converting one to the other.
It was the best in the world at it. The key was exchanging that potential energy altitude for an absolutely overwhelming amount of kinetic energy or speed, and doing it faster and more safely than any other fighter in the sky.
So walk us through how that works. Why was the Thunderbolt so good at this?
Well, first, that big R2800 engine and its turbo-supercharger meant the P-47 loved high altitude. It performed beautifully up at 30,000 feet or even higher.
So they could start the fight from way upstairs. They had a huge potential energy advantage from the get-go.
Exactly. They would climb and cruise high above the German formations, essentially storing energy in the bank. And then second, the airframe itself was built to withstand the enormous stresses of a high-speed dive.
This is the critical part, right? It could dive at speeds that other planes just couldn't handle.
It could dive almost vertically, pushing 550, maybe even close to 600 miles per hour in some cases. Pilots reported the controls getting incredibly stiff.
That's compressibility, right? The air starting to pile up on the wings as you get close to the sound barrier.
That's exactly what it is. The P-47's thick, rugged wings and heavily reinforced structure were designed to handle those forces. It was built for that stress.
So what happens if a German pilot in a Bf-109 tries to follow a Thunderbolt into one of those dives?
He's signing his own death warrant. The Bf-109, the SW-190, they were much lighter planes with thinner wings. They had a much lower, never-exceed speed.
So if they tried to keep up,
they'd experience violent control lockup where the controls just freeze. Or worse, structural flutter, where the wings and tail start to oscillate violently and then just disintegrate. They would literally tear themselves apart in midair.
So the P-47 had a complete monopoly on that high-speed vertical attack. The Germans couldn't follow them down.
They couldn't.
Yeah.
It gave the American pilots a safe escape route every single time.
Okay, so let's walk through the boom and zoom cycle. This wasn't about sticking around and dogfighting.
No, it was a pure high-speed hit-and-run tactic. It was almost like an assassination. You start high above the enemy, you pick your target.
Then you commit. You push the nose over.
You go into a steep, near-vertical dive. You're converting all that altitude, all that potential energy into a tremendous amount of speed. You are now moving hundreds of miles an hour faster than the enemy's maximum level speed.
You come screaming down on them like a hawk. That's the boom.
That's the boom. You execute your firing pass at the bottom of the dive at maximum velocity, and then, and this is the most important part, you do not stay and fight.
You don't try to turn with them.
Never. You use all that incredible kinetic energy you just built up to perform the zoom. You pull up into a steep, high-speed climb, rocketing back up to the safety of high altitude.
Using your speed to regain the altitude you just spent.
You're essentially putting the energy back in the bank. And you leave the German fighters wallowing below, unable to follow you into the dive, and too slow to catch you in the zoom climb.
So you're dictating every single aspect of the engagement.
100%.
Yeah.
You decide when to fight, where to fight, and when to leave. You force the Germans onto the defensive. All they can do is try to dodge you or watch you disappear.
It completely neutralizes their advantage in turning ability.
Because you never give them the chance to use it.
Yeah.
They're not playing their game anymore. The P-47 turned aerial combat into a brutal game of gravitational physics, and because of its mass and its strength, it always held the winning cards.
It's almost like aerial guerrilla warfare.
That's a great way to put it. It proved that in this high-speed, high-stakes environment, raw power and the ability to manage energy could be far more decisive than nimble agility. Cartvelli's dinosaur had found its perfect hunting ground.
Okay, so we've covered the zoom. Let's talk about the boom. When that 7-ton Thunderbolt screamed down at 500 miles an hour, what exactly was it bringing to the party?
It was bringing a philosophy of firepower that was just as brutal and unsubtle as its engineering. Sheer, overwhelming volume.
We're talking about the guns.
We are talking about 8.50 caliber M2 Browning heavy machine guns, 4 mounted in each wing.
8? That's a staggering number compared to its contemporaries. A Spitfire might have had rifle caliber guns, and the Germans were big fans of cannons.
Right, and that's a key difference. The German philosophy was about a single, powerful, explosive hit. Their 20mm or 30mm cannons were devastating, but they had a slow rate of fire and very limited ammunition.
You might only have 60 rounds for your main cannon. You had to make every shot count.
They were precision instruments, designed to take down a big bomber with 1 or 2 well-placed shells. The P-47 was the complete opposite. It wasn't a scalpel. It was a sledgehammer, a saturation weapon.
And the .50 caliber round itself was a huge step up from the smaller machine guns used earlier in the war.
Oh, massively. The 50 cal was incredibly reliable, it had a high rate of fire, and the projectile itself was big and heavy. It had a great trajectory, long range, and fantastic penetration.
It could chew through armor and engine blocks.
It could, but the real magic happened when you combined all 8 of them. They were synchronized, harmonized, to all converge at a specific point out in front of the aircraft.
The convergence zone.
Exactly. And when a P-47 pilot pressed the trigger, it didn't just send a stream of bullets at the target. It created what pilots called, for very good reason, a literal wall of lead.
A wall of lead. I mean, just quantify that for us. How much metal are we talking about?
The numbers are just mind-boggling. The M2 Browning fires at a rate of, say, 800 rounds per minute. With 8 guns firing at once, a 1-second burst puts more than 130 heavy projectiles into the air.
So a quick 2-second burst.
A 2-second burst puts nearly 200 rounds into that convergence zone. It's almost impossible to survive that. You couldn't fly through it.
No aircraft could withstand that kind of punishment.
Nothing. It didn't matter how tough you were. Enemy planes weren't just damaged or crippled by a P-47's attack. They were often seen to just disintegrate. They were pulverized. They would explode instantly as hundreds of armor-piercing and incendiary rounds hit them all at once.
And the pilot had plenty of ammunition to work with.
That was the other huge advantage. The P-47 could carry over 2,000 rounds, sometimes more. That's the American industrial logic again.
Right. A German pilot might be heading home after 2 or 3 firing passes.
While the Thunderbolt pilot could stay in the fight, engage multiple targets, and still have ammo to spare for strafing on the way home, it completely changed the operational tempo of a mission.
And the sound of that weapon system must have been something else.
It was terrifying. It wasn't the sharp crack of a cannon. It was this deep, heavy, rhythmic thumping. A sustained mechanical roar.
And the pilots had a nickname for it.
They did. They called it Roosevelt's piano.
That's perfect.
Isn't it? That powerful rhythmic sound meant the full industrial might of the United States had just been focused into a single point in the sky, and it was aimed directly at you. For a German pilot, hearing Roosevelt's piano meant you had maybe 1 second to live.
So you have this perfect combination. The zoom gets you there and gets you out safely.
And the boom ensures that whatever you pointed your nose at simply ceased to exist. It was the ultimate synthesis of speed, resilience, and just awe-inspiring, overwhelming firepower.
So we've seen how this flying milk bottle became a truly dominant air-to-air fighter. It overcame its weaknesses through smart tactics and by leaning into its strengths.
Right. But the P-47 wasn't a static design. It was constantly being refined, constantly improved, and one mid-war upgrade in particular addressed its last real weakness.
And that was its climb rate, right? The Germans could still sometimes escape by going straight up.
They could. The early models were a bit sluggish in the initial climb. The power was there, but it wasn't translating to vertical performance as well as it could. And that was solved by, of all things, a new propeller.
Just changing the propeller, how could that make such a big difference?
It was a huge difference. They introduced these new, broad paddle blade propellers. They had much wider, almost square-tipped blades.
So they could grab more air with each rotation.
Exactly. They were much more efficient at converting the R-800's incredible horsepower into actual thrust, especially at lower speeds during takeoff and in a climb. It was like putting much bigger tires on a muscle car.
And suddenly, that last escape route for the Germans was gone.
It was slammed shut. The P-47 could now climb right up there with the best of the German fighters. There was no running, and there was no hiding. It was now a complete high-energy fighting machine.
So by 1944, it's this incredibly durable, fast-diving, fast-climbing, heavily armed monster. But its biggest contribution to the war was arguably still to come.
That's right. As the Allies prepared for the invasion of Europe, the nature of the air war began to shift. It wasn't just about bomber escort anymore. It was about controlling the battlefield.
And the Thunderbolt was perfectly suited for the ground attack role.
It was a natural fit. That same robustness that allowed it to survive cannon fire meant it was incredibly resistant to flak and small arms fire from the ground. It could fly low and slow over the target area in a way that would have been suicidal for a Spitfire.
And it could carry a serious amount of ordnance.
It could carry a massive bomb load, up to 2,500 pounds of bombs, or, even more terrifyingly, it could carry racks of high-velocity rockets.
Which were devastating against tanks and trains.
They were armor killers.
Yeah.
But even without the bombs and rockets, those 8.50 caliber machine guns were probably its most effective ground attack weapon.
For strafing.
For strafing anything that moved. The P-47 became the bane of the German army's existence. Pilots were tasked with crippling German logistics. They hunted trains, truck convoys, supply depots, troop columns.
They essentially made it impossible for the Germans to move men or material during the daytime.
They completely paralyzed them. And the psychological impact of that constant looming threat was just crushing.
This is where we get the term Jabo fever.
Exactly. Jabo was the German slang for Jagdbomber, or fighter bomber. And Jabo fever was a real documented condition.
A kind of battlefield PTSD caused by this one aircraft.
It was. German soldiers on the front lines developed acute anxiety, stress, sometimes even physical sickness, just from the constant fear of a Thunderbolt attack. They knew that any movement, any sign of life, could bring these things screaming down out of the sky with no warning.
It's not just a weapon at that point, it's psychological warfare.
It was total war delivered from the air. The P-47's ability to just linger, to absorb punishment and keep attacking, made the ground completely untenable for the enemy. It was the physical embodiment of Allied air supremacy.
And this all comes back to that core industrial philosophy that made the plane possible in the first place.
It does. And one of the most respected German aces, General Adolf Galland, he saw this very clearly. He understood what they were really up against.
It wasn't just the plane, it was the system that built it.
Galland realized that while German engineering was often brilliant, maybe even more technologically advanced in some areas, it was a boutique industry. They were building exquisite, complex machines that were hard to mass produce and hard to maintain.
Well, the Americans were just churning out thousands of these rugged, effective, easy-to-fix machines.
Galland said it himself. The war became a numbers game. The U.S. built over 15,000 P-47s. 15,000 of these complex, powerful, resource-intensive aircraft.
With a constant supply of spare parts, new engines, and ammunition to feed them.
Germany simply couldn't compete with that. The P-47 wasn't just a great fighter, it was the relentless, unstoppable product of an industrial philosophy that valued robust, scalable mass production over delicate tactical genius. And in a long war of attrition, that's the philosophy that wins. #tag outro.
What an incredible arc. From flying milk bottle to the terror of the Western Front, the story of the P-47 is just a masterclass in how a derided concept can become a legend.
It really is. And the whole story is summed up perfectly by the people who had to face it. We have this quote from a captured German pilot late in the war, 1945.
And it really shows how much their perspective had changed from that first day in 1943.
Completely. He reflected on the first time they saw the Thunderbolts and what they learned.
What did he say?
He said, "We laughed when we first saw them. We stopped laughing when we realized they didn't need to turn. They just pointed those guns at you, and you ceased to exist."
Wow. They didn't need to turn. That's the whole story in one sentence.
It is. Maneuverability, elegance, all the things they valued. They were irrelevant in the face of that kind of overwhelming high-speed force.
So if we pull back and look at the bigger picture, what does this all mean? The Thunderbolt's success was really about prioritizing a few key things: durability, power, and overwhelming force over everything else.
Right. Carvelli and Republic Aviation made a bet. They bet that in a massive industrial war, a resilient, easy-to-produce weapon system would ultimately beat a more refined but fragile one. And they were right.
Which brings up a really interesting question, I think. One for you, the listener, to chew on.
Yeah, it applies to so much more than just airplanes. If you look at any complex, high-stakes system, whether it's in the military or in business or technology development.
Is it possible that robust, scalable mass is often more strategically decisive than elegant but limited brilliance?
The P-47 story seems to suggest that maybe it is. That sometimes the best strategy isn't to build the most clever or technically beautiful solution, but to build the one you can make 15,000 of.
The one that can take a punch and just keep on coming.
A powerful reminder that sometimes the dinosaur is the one that wins the war.
A fascinating place to leave it. Thanks for joining us for the deep dive.
My pleasure. Until next time. Welcome to the deep dive. We're continuing our analysis of, well, one of the most deceptively effective military aircraft ever conceived, the P-47 Thunderbolt.
It's a fascinating machine because when it first lumbered onto the European stage, its reputation was almost as heavy as its frame.
Right. It was just massive, it looked clumsy, and it earned that distinctly unglamorous nickname, the flying milk bottle.
And that initial perception is so crucial because it really sets the stage for the machine's unbelievable transformation. I mean, many of its enemies and honestly some of its own proponents, they initially dismissed it.
saw it as a heavy, fundamental misunderstanding of what a fighter plane should even be.
Exactly.
So today, our mission is to peel back that early reputation. We're going to dive deep into the specific technological, tactical, and maybe most importantly, the industrial shifts that took this struggling design.
And by early 1944, forged it into what our sources universally describe as an instrument of total annihilation.
The aha moment we really want you to experience here is this. The P-47 did not win the war through elegance. It wasn't about outturning a Spitfire or, outclimbing an early Messerschmitt based on some kind of aerodynamic purity.
No, not at all. Its dominance was rooted in raw, just overwhelming industrial might, and that was coupled with some specific, brutally effective engineering fixes that turned its greatest weakness into a devastating strength.
Exactly. That shift from an aircraft that was frankly struggling for survival in the escort role to this dominant force.
A force that could not only survive, but actually dictate the terms of engagement, one that could stay with the bombers all the way to Berlin.
That wasn't a gradual change. It really hinged on a single game-changing technological leap.
That's the key pivot point. It went from merely existing in the enemy's airspace to truly owning it.
Okay, so let's start there. Let's start with the immediate and most glaring problem the early Thunderbolt faced.
Its difficulty in climbing. It was just an awful climber, especially when you compared it to the highly optimized, much lighter German interceptors.
And that initial struggle, it really defined the early air war for the P-47. The German tactical handbook was simple, wasn't it?
Oh, absolutely. Bounce the P-47s from high altitude, force them into a turn, exploit that vertical advantage, and then just dive away.
Knowing full well the big American plane couldn't follow them up.
It was their expected, reliable advantage. And, that expectation was sound. It was based on physics.
The P-47 was built around that colossal Pratt & Whitney R2800 double Wasp engine.
A powerhouse. I mean, we're talking over 2,000 horsepower, the single most powerful radial engine in Allied service at the time.
But all that horsepower is useless if you can't efficiently translate that rotational force into thrust.
Especially in the thin, high-altitude air where all the real combat was taking place.
So the problem wasn't a lack of power. It was really a crisis of efficiency. How do you take that immense torque and turn a plane that weighs almost 10 tons fully loaded into an efficient climber?
And the solution, it's fascinating. It didn't come from another engine redesign or some major airframe modification. It came from the very tip of the plane.
The propeller.
The propeller. The introduction of the Hamilton Standard Hydromatic Propeller, which pilots immediately nicknamed the paddle blade.
And that single piece of engineering just revolutionized the P-47's performance profile almost overnight.
It really did. Let's unpack the genius of that thing, because when you look at old photographs, the size is just staggering.
It's huge.
It is. Early P-47 props were smaller, they were narrower, and they just struggled immensely to absorb the massive force of that R2800 engine.
Right, you're trying to put too much power through too small a surface.
And when you do that, you run into all sorts of issues, like the blade tips exceeding the speed of sound, creating shock waves. You lose all efficiency, especially up high.
And the paddle blade fixed this by essentially creating massive oars, right?
Precisely. We're talking about a propeller assembly that was 13 feet in diameter.
13 feet. That's why it needed that huge, wide landing gear stance.
It's a big part of it, yeah. The blades themselves had these dramatically broader chords, so you should think less like a knife cutting through the air.
And more like a huge, thick paddle just grabbing and throwing massive amounts of air backwards.
That's the perfect analogy. It was all about maximizing the surface area to make sure every single unit of the engine's torque was converted into thrust, even at 30,000 feet.
Okay, so the technical description is impressive, but the performance numbers, that's what really tells the story. Before this upgrade, what are we looking at?
Before the paddle blade, the P-47's climb rate was, as one of our sources puts it, anemic.
Anemic.
We're looking at figures around 2,200 feet per minute. And at that rate, a German fighter operating with a vertical advantage can dictate the entire fight.
And just leave whenever they want.
Exactly. But with the new propeller in place, the change was dramatic.
So what did it jump to?
It shot up to over 3,000 feet per minute.
Wow. That's a massive difference.
That single change, a technical refinement at the very front of the aircraft, transformed the P-47 from a defensive player into an aggressive climber.
Which means the Thunderbolt could now match or even beat the climb rate of many of his opponents, completely erasing that fundamental German tactical edge.
And this is where the historical shock factor comes in. Because the news of this upgrade, it didn't travel as fast as the planes themselves.
So the German pilots were still flying with old intelligence. They thought they knew exactly how a P-47 would respond to an attack.
And that lag in intelligence, it led directly to some of the most stunning reversals of fortune in the air war. The anecdote involving Hauptmann Heinz Nock is the perfect example.
Nock was an established ace, a very experienced pilot.
Highly experienced. And he spots a formation of Thunderbolts, the same heavy fighters he was used to, mocking.
So he does the standard proven attack, dive on the formation, hit and run, and then use the P-47's expected sluggishness to climb away to safety. He expected the usual advantage.
His strategy was flawless, based on everything he knew, but the reality he encountered was utterly new.
So instead of the Thunderbolts trying to roll away or just struggling under the attacks,
they did the unthinkable. They turned into the climb, they responded aggressively and pursued the German fighters.
not just for a little bit.
No, not just to a safe altitude. They followed them all the way up to 30,000 feet.
And this wasn't just a pursuit. It was a complete, devastating role reversal.
Nock watched his wingman get destroyed right next to him during that high-altitude scramble. And the moment of realization, of true terror, I imagine, came when he grasped that the tactical rules had just been completely rewritten.
His quote is legendary because it just perfectly defines the P-47's emergence.
He said, "These are not the same machines we laughed at last year."
The heavy fighter, once seen as a conceptual failure, was now a serious high-altitude vertical fighter. It robbed the Luftwaffe of one of their most reliable escape routes.
Okay, so that's the engine and mobility fix. But once the P-47 had that altitude advantage and could stay in the fight, it needed to make sure that engagement was decisive.
Which brings us to Section 2, the sheer, brutal sledgehammer of its firepower. The performance upgrade gave it reach. The ballistics gave it devastating killing power.
Right. And to talk about firepower, we really have to look at the fundamental philosophical difference between the American and German approaches to armament.
The Luftwaffe tended to favor powerful but low-count cannons. 20, even 30-millimeter guns.
Yeah, guns that could, in theory, destroy an aircraft with a single, well-placed hit. But they required pinpoint accuracy, and critically, they had very low ammunition reserves.
It was a philosophy of precision, of the individual ace. The American approach, especially with the P-47, was the complete opposite.
It really was. It was a philosophy of attrition, of volume, of redundancy.
Why try to hit a plane with one 20-millimeter shell?
When you can absolutely saturate it with a continuous stream of 50 caliber rounds.
And that volume is genuinely staggering. The P-47 carried 8.50 caliber machine guns, 4 in each wing.
With a total ammunition load of 3,400 rounds.
Wait, 3,400. Let's try to put that into context.
Oh.
That amount of ammunition means a P-47 pilot could sustain bursts of fire for far, far longer than any German equivalent.
And critically, if one or two guns jammed, which was common in combat,
you still had 6 functional guns delivering phenomenal volume. That redundancy, again, it just screams industrial design.
it does. And that volume wasn't just random spray and pray. It was optimized to create a literal curtain of destruction.
The pilots would tune their guns,
Right.
not to fire parallel, but to intersect.
To converge, yeah. At a specific range, usually about 300 yards in front of the aircraft.
So what did that do to the density of the firepower if you were an enemy plane at that 300-yard mark?
It created what they called a convergence zone, a lethal cone of fire where 8 streams of bullets, each firing at around 750 to 850 rounds per minute, all cross paths.
So if an enemy aircraft, which is not a large target, flew into that zone,
They were being hit by roughly 100 projectiles every single second.
100 per second, that's not a burst. That's a sustained high-velocity stream of metal just tearing into the airframe.
And the kinetic energy alone would be horrific, but that's only half the story, isn't it?
Right, because they weren't firing standard ball ammunition. This is where the destruction gets truly terrifying.
Exactly. The ammunition was highly specialized. It was primarily armor-piercing incendiary, or API rounds.
The perfect combination for attacking metal airframes.
It was. The armor-piercing core was designed to punch through the thin aluminum skin and the internal structure of the target aircraft. But the real kicker
Was the incendiary component.
a small chemical payload, usually magnesium or white phosphorus, designed to ignite once it was inside the airframe.
So you get a twofold effect. You punch the hole, and then you guarantee the aircraft catches fire.
And not just any fire. It would ignite fuel, hydraulics, oxygen systems, even the aluminum structure itself. The combination was just brutal.
And you see that in the accounts from the major bomber raids like the Schweinfurt missions.
Oh, absolutely. The sources mention the Messerschmitt 110s, which were these twin-engine interceptors often sent up against the bomber formations. They were pretty fragile compared to the single-engine fighters.
So what happened when one of them flew into that convergence zone?
Pilots described them as being literally cut in half. The sheer velocity and density of the fire just meant that the 110s, they didn't just take damage, they disintegrated.
They became, in the harrowing phrase from one source, metal confetti.
It's chilling. The P-47 wasn't designed for a graceful dogfight. It was designed to deliver overwhelming, structurally annihilating damage the instant a target entered its killing cone.
That is the perfect summary. It was built for destruction, and as the air war progressed, the P-47's success in decimating the Luftwaffe's fighter arm meant it had fewer targets up high.
And this is where the machine found its true, devastating versatility, the transition to ground attack. This defined Section 3, the Jabo era.
A transition that was almost seamless for the Thunderbolt.
Because of its rugged construction and its colossal payload capacity. The very qualities that made it so heavy in the air, the robust frame, the massive engine, the wide wings, made it an ideal, durable platform for hauling tons of ordnance close to the ground.
Let's define that term the Germans came to fear. Jabo.
It's short for Jag bomber, fighter bomber. It was a role that leveraged the P-47's inherent durability to withstand anti-aircraft fire while delivering destruction that really few other single-engine fighters could even hope to match.
And by June 1944, leading up to D-Day, the P-47 became quite literally flying artillery.
The payload is just mind-boggling. It could carry a bomb load equivalent to what early war medium bombers like the B-25 Mitchell carried.
We're talking up to 2,500 pounds of external ordnance plus rockets.
The 5-inch high-velocity aircraft rockets, the HVARs, those were a game changer for ground attack.
They really were.
The HVARs had the kinetic energy and destructive power of a medium artillery shell, but delivered with the precision of a dive-bombing attack.
So the psychological warfare impact here must have been immense. It wasn't just the physical damage, it was the constant, unavoidable threat overhead.
A threat that just broke the German will to move during the day. The troops on the ground, the Wehrmacht, they quickly coined a terrifying nickname for approaching P-47s.
Because of the specific sound they made in their high-speed dives.
Donnerschlag. Thunderclap.
And that sound didn't mean a potential fight was coming.
No, it meant the imminent, overwhelming certainty of destruction.
And the ground commander's reports from that period, they just paint a picture of total logistical collapse. They weren't just being hampered by air superiority, they were being systematically annihilated.
You read accounts from panzer commanders desperate for fuel and spare parts, and they report that entire collars of trucks, essential for maintaining any kind of mobility, would simply cease to exist in a single pass.
In a single pass.
By a flight of Thunderbolts. This is total disruption. It's not just a localized tactical success. It's strategic paralysis delivered by one type of aircraft.
Let's quantify that paralysis. The statistics from the 9th Air Force for June 1944 alone, the month of the Normandy invasion, are just incredible.
They claimed nearly 4,000 trucks and over 600 locomotives destroyed.
Think about that. 600 locomotives. What does that do to a supply system that relies on rail transport?
It means massive delays. It forces reliance on unreliable roads, and it creates constant bottlenecks. When you take out the ability to move heavy equipment and supplies, you functionally amputate the Army's logistical leg.
So the strategic reality became simple and brutal. The German Army could only move at night.
Under cover of darkness, and even then, it was risky. Daylight movement meant certain death from the Donnerschlag.
The P-47, the former flying milk bottle, had effectively shut down the primary ground logistics networks across the entire Western Front.
And this systemic shutdown leads us right to the most critical section of this deep dive, the true core advantage that made the P-47 so unstoppable. It wasn't just a plane.
It was the physical result of an ideology based on attrition, backed by the greatest industrial avalanche the world had ever seen.
This is where we shift focus entirely. We stop talking about the machine's performance specs and start talking about the system that was supporting it.
The P-47 was merely the most durable, visible component of America's overwhelming industrial capacity.
And nothing illustrates the terrifying, relentless nature of this advantage better than the events of Operation Bodenplatte. New Year's Day, 1945.
The Luftwaffe's last, desperate, massive surprise offensive.
aimed at destroying Allied air power on the ground, hoping to buy some time for the faltering Ardennes offensive.
And the Germans committed significant and irreplaceable resources to this gamble. They hit multiple Allied airfields, and they did achieve some tactical success. They surprised Allied personnel and destroyed a lot of parked aircraft.
Yes, the attack was costly for the Allies. At one airfield near Metz, which housed a P-47 group, the German raid was particularly successful in the short term. The sources say 22 Thunderbolts were destroyed on the ground.
A significant material loss.
It was, and this leads to the moment that, for me, captures the entire industrial conflict in a single legendary exchange.
A captured German pilot, seeing the smoke rising from the P-47s he'd just helped destroy, couldn't resist taunting the American commander, a Major George Brooking.
The German pilot was proud, naturally. He was pointing at the destroyed airframes, reveling in the successful material blow they had delivered. He saw the wreckage, the economic cost.
But Major Brooking had a perspective, a comprehensive industrial perspective, that the German pilot just could not grasp.
His response is the ultimate mic drop, the definitive statement on the true nature of the war. He didn't deny the damage.
Instead, he pointed across the field to the flight line, where crews were already clearing the debris.
He looked the captured pilot straight in the eye and said, "By tomorrow, we'll have 40 new ones."
Wow.
How long will it take you to replace your pilots?
That exchange just crystallizes the entire strategic reality.
It does. In that single, desperate operation, the Luftwaffe lost over 200 of its most experienced, highly trained, and critically irreplaceable pilots.
These were men who had survived years of intense combat. Their skills couldn't be duplicated quickly.
And the American loss, 22 airframes. The American industrial system replaced that material loss within 48 hours.
With brand new planes that had probably rolled off the production lines just days before.
That is the difference between a system designed for attrition and a system struggling for survival. The P-47 was not just a fighter, it was the ultimate sledgehammer weapon of an overwhelming industrial capacity.
And its design, its durability, its ability to take damage and still bring the pilot home was an integral part of that industrial dominance.
Absolutely. The durability of the P-47 meant that when an American plane took a hit, the pilot often survived to fight another day. When a highly specialized German plane took a hit, it often took its irreplaceable pilot with it.
It wasn't a fair fight. It was an economic and human resource demolition.
And the sheer volume of P-47 production, we're talking over 15,600 units built, meant that even if the Germans fielded a slightly more elegant fighter, they were just buried under the sheer weight of manufacturing volume.
Which brings us to the most incredible part of the P-47's career, how it adapted to fight the future of air combat.
The jet challenge. The Messerschmitt Me 262. By late 1944, this thing was introduced, and it was a technical marvel. A full 100 miles per hour faster than the Thunderbolt.
Theoretically, the jet should have made the P-47 obsolete instantly. It could engage or disengage whenever it wanted.
No propeller-driven aircraft, especially one as heavy as the Thunderbolt, should have been able to compete with that kind of speed differential.
But the P-47 pilots, true to the rugged nature of their machine, found ways to defeat the future by leveraging the one thing everybody mocked about it.
Its massive weight and its robust construction. They turned weakness into a weapon yet again.
How?
Well, since the jet was faster in level flight, the P-47 pilots mastered the dive. They would climb to extreme altitudes and use the P-47's huge mass and gravity to their advantage,
Pushing the machine to incredible speeds.
sometimes approaching the sound barrier.
Wait, approaching the sound barrier in a propeller plane from that era? That sounds incredibly risky. How did the airframe even survive that kind of strat?
That's a crucial point. Lighter, more aerodynamically clean fighters of the time, like the Spitfire, they often struggled with high-speed compressibility.
Where the air stops flowing smoothly over the wings and you lose control.
You lose control or the wings just flutter apart. The P-47, being so rugged and heavily built with robust control systems, was structurally sound enough to survive those extreme G-forces and speeds. It could temporarily match the jet's speed in a dive.
So they would catch the Me-262 in a dive, but the real tactical ambush came when the jets were forced to slow down.
Exactly. The jet's speed advantage completely disappeared when it was most vulnerable. P-47 pilots specialized in what they called rat trapping.
Ambushing the jets as they were slowing down for landing or during the initial climb after takeoff.
Yeah, the jet engines of that era were temperamental, they guzzled fuel, and they provided almost no thrust at low speeds. It left the Me-262 essentially defenseless against a well-executed attack run.
And the analysis from Major George Bostwick, a P-47 pilot who flew against them, it perfectly sums up this operational contrast. He said that while the jets were incredibly fast, they were ultimately fragile.
That fragility was a fatal flaw against the P-47's durability and firepower. Bostwick's quote is stark: "One good burst, and they come apart like they're made of paper."
The high-performance engineering of the jet was delicate.
Very delicate. While the P-47 could absorb dozens of hits and still get back to base, it only needed one clean burst of API rounds to shatter the structurally lighter Me-262.
And once again, this connects right back to the industrial and human factor. The P-47 pilots were veteran aviators, kept alive by the durability of their planes.
While the late-war German jet pilots rushed through training were dangerously inexperienced, they lacked the combat savvy to use the jet's potential and navigate its vulnerabilities.
So the Thunderbolt didn't just defeat the jet on aerodynamics or engine power.
It defeated the jet on logistical resilience and pilot quality. The P-47 was rugged enough to ensure experienced pilots came home. The Me-262, when hit, often eliminated both the machine and its hastily trained pilot forever.
So what's the final tally? What's the final ledger for the flying milk bottle?
By the end of the war, the statistics are just a testament to unparalleled destruction. The Thunderbolt had destroyed over 7,000 enemy aircraft, both in the air and on the ground.
It secured its place as one of the most vital and, you could argue, most underrated combat aircraft in history.
And the most compelling evidence of its success came from the enemy high command. The final verdict, really, it belongs to General Adolf Galland, the highly respected head of the Luftwaffe fighter arm.
Galland recognized the fundamental, fatal mistake the Luftwaffe had made early on. They had looked at the massive, heavy P-47 design and concluded that the Americans didn't understand air combat.
They equated light, fast, and elegant design with inherent superiority. They were completely caught in the mindset of the aerial duel.
Focus on turn radius and rate of climb metrics, where their fighters initially excelled.
And they completely failed to grasp the strategic calculus of total war against an industrial giant. Galland, at the end, he finally understood the true American genius.
That in a war of attrition, the plane that could take punishment and deliver devastating firepower would win.
That concept, durability, married to devastating volume of fire and production capacity, it rendered the elegance of the German design and the skill of their pilots strategically irrelevant.
They couldn't replace their losses, while the P-47s just kept coming.
And it leads us directly to the powerful, sobering, and undeniable conclusion from Galland's comments and the war's operational reality.
Courage without resources is just delayed defeat.
That is a truth that defines industrial warfare. The P-47 Thunderbolt, the machine everyone mocked, became the definitive example of victory achieved not by subtlety, but by manufacturing might.
It literally buried the enemy under an avalanche of aluminum, API rounds, and relentless production quotas.
It's a critical historical lesson that goes way beyond aviation. Superior technology in small numbers, like the Me-262, cannot ultimately overcome the relentless, overwhelming force of industrial might.
Especially when that might is applied through intelligent engineering fixes that eliminate key weaknesses, like that propeller upgrade.
We've traced the whole evolution. The technical brilliance of the paddle blade propeller, the brutal effectiveness of the convergence zone, the strategic paralysis caused by the jabo roll.
And the defining, overwhelming role of industrial capacity. Quantity in this conflict developed a quality all its own.
So as we conclude this deep dive, we want to leave you with a thought to chew on. The P-47 was the physical embodiment of an overwhelming manufacturing-based dominance, a machine often dismissed for being clunky, yet proving decisive.
Think about that concept of attrition and industrial capacity. What modern equivalent, maybe technological, logistical, or even in the realm of software and data, represents that same overwhelming resource-based dominance today?
What is the current sledgehammer weapon that might be dismissed for being too clunky or too mass-produced, but is ultimately being built in such volume that it ensures victory simply through sheer, relentless attrition and durability?
Consider where we see resource superiority being leveraged to make superior yet fragile technology strategically irrelevant.
It's a pattern that repeats throughout history, long after the Donnerschlag fell silent over Europe.
Thank you for joining us for this extensive analysis of the P-47 Thunderbolt. Until our next deep dive.
Okay, so this is it. We've reached the final destination of our journey into, I think it's fair to say, one of history's most genuinely influential combat aircraft.
The P-47 Thunderbolt.
The Thunderbolt, exactly. We've already covered its really awkward start, its infancy.
And we've analyzed its absolute mastery of the close air support role in Europe.
Yeah.
Became a legend there.
But today, we're shifting gears. The perspective is completely different. Our sources they're less focused on the individual dogfights and more on the grand global scale.
The industrial machine that actually forged the weapon.
Yes, the machine behind the machine.
That's absolutely right. The Thunderbolt, or the Jug, as it's called.
Right.
It's so often just anchored in our minds to those muddy fields in the UK or the skies over Germany.
Right.
But this deep dive really forces us to look past that. We're going to be examining its paradoxical role in the Pacific theater, which is a whole different story.
And crucially, dissecting the engineering and the industrial engine that was the real source of its success.
That's the core of it.
So the mission for you listening to this is to really get a handle on how this 7-ton monster, a plane that was, let's be honest, initially criticized for being too heavy, too slow.
A flying bathtub, they called it.
Exactly. How did it not just survive, but become the ultimate manifestation of American industrial and engineering superiority? It became, in the words of its own opponents, an unsurvivable force.
It's really a story of logistics and sheer volume winning a war, all wrapped up in a very, very tough aluminum skin.
Okay, so let's start with what you called the paradox, the Pacific.
The Pacific paradox, yeah.
Because if you want a perfect picture of how, industrial might can just completely overturn traditional design ideas, you have to look there.
The contrast is it's startling. You have, on one side, the Japanese A6M0.
A masterpiece of lightweight design, incredibly agile, built for one thing and one thing only, maneuverability.
Right. They sacrifice everything for it. Pilot armor, self-sealing fuel tanks.
Yeah.
All of it was stripped out just to shave off a few more pounds. It was made of, the lightest materials possible.
Almost gossamer, like you said. And then against that, you have the American entry.
The P-47 Thunderbolt. The Jug.
It's massive. It's loud. It's a 7-ton metal monster. A brute.
It was built around the most powerful engine they could find, that huge Pratt & Whitney R2800 double wasp, and then wrapped in a heavy-duty structure that could just absorb incredible punishment.
So on paper, if you're thinking about a classic slow-speed turning dogfight,
it looks like a complete mismatch.
In favor of the Japanese.
Absolutely.
Yeah.
But reality turned out to be very different. And that was proven pretty early on in places like New Guinea with units like the 348th Fighter Group.
Led by Colonel Neil Kirby.
Right. And what they proved was that the basic physics of the P-47's design, its mass, its incredible durability, and that monstrous engine power, it just trumped the Zero's agility.
But only in the kind of fight the Americans chose to have.
And that's the key. They imposed their own rules. They didn't get into slow-turning fights. They used high-speed, hit-and-run tactics.
So when you say physics 1, what does that actually mean in the air?
It means kinetic energy. Pure and simple. That R2800 engine was putting out over 2,000 horsepower. It allowed the P-47 to achieve phenomenal diving speeds.
And a Zero just couldn't follow.
It couldn't. Its lighter construction, its smaller engine, it would literally tear itself apart if it tried to keep up in a high-speed dive.
The pilots knew it.
So that's the crucial technical point. The Zero pilots were actually afraid of their own planes at high speed.
They were terrified. Pushing the controls too hard in a dive meant risking, catastrophic structural failure. The wings could just shear off from flutter or G-loading, and that's not even getting into compressibility effects as they approached high Mach numbers.
So their only escape route was also potentially a death sentence.
Exactly. The Thunderbolt was the complete opposite. It was a rock. It was an incredibly sturdy platform designed specifically to leverage the power of that engine.
An engine so durable it could famously take cannon hits and just keep on running.
Which brings us to what the Japanese pilots themselves thought. The famous ace, Saburo Sakai. He had a very simple description for the P-47s. We called them monsters.
Monsters. And that's coming from one of the best. It's a chilling quote because you can feel the helplessness in it.
He talks about emptying his cannons into a Thunderbolt, weapons that would just disintegrate other Allied planes.
You'd see plating fly off, chunks of metal. He's waiting for the explosion.
And the P-47 just flies on. It just maintains its course and speed and flies away.
It's just a perfect encapsulation of that fundamental difference in engineering philosophy. The Japanese goal was maximum offense for minimum weight. The result was a fragile aircraft.
A glass cannon.
A perfect description. A single good burst, and they would often just come apart. No armor plating, no self-sealing fuel tanks. They were designed to deal death, not to take it.
The Thunderbolt, on the other hand, was designed from the ground up to be a tank in the sky, to protect the pilot.
Its job was to survive the fight, even if it was grievously wounded.
Yeah.
This concept of battle damage tolerance meant that even if a P-47 was hit, it could almost always use its superior speed to break away, dive, and just limp home.
So its durability solved the tactical problem of surviving a fight. But that brings us to the biggest strategic problem in the Pacific.
The tyranny of distance.
Yes, something Europe didn't really have in the same way. The distances between islands, let alone from Allied bases to the Japanese mainland, were just colossal.
And the early P-47, which was designed for missions over France, was what they called short-legged. It just didn't have the range.
This is where that American industrial system you mentioned really shows its genius. Because they didn't scrap the design.
No, they revolutionized it. They adapted it to solve this massive strategic problem. And that led to the ultimate evolution of the airframe, the P-47N.
This wasn't just a minor tweak.
Oh, no. It was a wholesale re-engineering of the basic structure.
And the key innovation, which sounds so simple but was actually incredibly radical, was the wet wing.
It's anything but simple.
Right. I want to pause here for a second because this concept is so much more complex than just, putting a tank in the wing.
It really is. A standard fuel tank is basically a removable bladder. A bag, essentially.
You put it in a compartment.
Exactly. But converting the wings themselves into fuel tanks, the wet wings, meant you had to seal off entire sections of the wing structure. The wing skin and the spars become the walls of the tank.
So every single rivet line, every joint has to be perfectly, immaculately liquid tight.
And you have to remember, this is the primary load-bearing part of the aircraft. It's handling immense G-forces in dives and turns.
You're turning a high-stress structural piece into a plumbing system. The level of manufacturing precision required for that is it's almost impossible to imagine.
One leaky rivet and you're losing hundreds, maybe thousands of pounds of precious fuel out over the middle of the Pacific Ocean.
And they had to do this without adding a ton of extra weight from internal bracing, because the whole point was to maximize the fuel load.
Precisely. They were basically giving the P-47 massive internal drop tanks, but without using up the external hardpoints needed for bombs or rockets.
So the result of solving this huge engineering problem?
It was transformative. The P-47N took that short-legged fighter and stretched its operational range to over 2,300 miles.
2,300 miles. That's the difference between being a local tactical fighter and a full-blown strategic weapon.
And that capability was absolutely essential for the B-29 Superfortress campaign against Japan.
Right, because the B-29s were flying these incredibly long missions and were vulnerable without escorts.
Exactly. The P-47N, arriving late in the war, could now fly with the B-29s all the way to the Japanese mainland and back, from bases like Iwo Jima.
Suddenly, distance was no longer a shield for Japan's industrial heartland.
The enemy could no longer rely on the vastness of the Pacific to protect them. So the P-47's success wasn't static. It was this constantly evolving, industrially backed response to the changing needs of the war.
Which proves that American industrial capability wasn't just about volume.
It was about the speed of technological adaptation at a massive scale.
And that thread, that adaptability at scale, it leads us right into the core theme of this deep dive.
The industrial verdict.
Yes. We have to shift our focus now, away from the cockpit and onto the assembly line. Because at the end of the day, the war wasn't just decided by who had the better plane in a one-on-one fight.
It was decided by who had the better economic system to produce and sustain that plane day in, day out.
This is where that term American sledgehammer really, really applies.
Oh, absolutely. The P-47 was a strategic weapon just by virtue of its existence in such numbers. It was the embodiment of overwhelming industrial logic.
Let's just look at the raw output figures. Republic Aviation produced over 15,600 Thunderbolts.
15,600. And to give you some perspective on that number, the Germans produced about 20,000 of their main fighter, the Bf-109.
But that was over a much longer period, right? From before the war even started.
A much longer span, spread across multiple factories and countless variants. The sheer concentration and rate of P-47 output was something the world had never seen.
Let's talk about that rate. The Farmingdale factory on Long Island. 1,000 units per month. 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 1,0 Our sources say it was operating at a peak velocity where a complete combat-ready P-47 was rolling off the production line.
Every single hour.
Every hour, 24 a day. It's difficult to even visualize that kind of rapid, consistent manufacturing of such a complex machine.
And that's the critical detail that gets lost when we just talk about volume. The complexity within that scale. These weren't simple machines.
No.
Each P-47 was an incredibly sophisticated piece of engineering. We're talking about an aircraft made of roughly 65,000 individual parts.
65,000. And that includes things like the turbo-supercharger system, which was unique to the P-47.
A complex system installed in the rear fuselage, which needed intricate ductwork and about 8 miles of wiring running through the entire airframe.
Okay, so you have all that internal complexity, hydraulics, radios, the turbo, and you're building one every hour while also holding to construction tolerances that are measured in 10,000ths of an inch. How? How do you achieve that level of precision at that kind of speed?
That is the genius of American standardization and quality control. Those tiny tolerances were absolutely critical for interchangeability.
So a part made in Farmingdale would fit a plane in New Guinea, no questions asked.
Perfectly. If a mechanic on a muddy airstrip needed a new engine mount or a wing panel, the part shipped from the factory had to fit without any special filing or retooling.
That level of industrial discipline enforced across a massive supply chain.
It allowed the P-47 to be repaired incredibly quickly and put back into service. So you weren't just winning in the factory, you were winning in the field by keeping the numbers up.
And who is pulling off this incredible feat of precision manufacturing? Our sources really emphasize the workforce.
The workforce was completely transformed by the war. It was largely made up of women, many of whom had absolutely no prior experience in heavy industry.
Some had never even seen an airplane up close before they walked onto the factory floor.
And yet they were achieving a level of precision that exceeded peacetime standards. It really reveals something profound about American industrial adaptability.
The system itself was designed for it.
The system was designed for modularity. Tasks were broken down into highly specialized, repeatable steps. This meant you could implement training programs incredibly quickly.
So you didn't need a master craftsman with a decade of experience.
No, you needed someone who could be trained to perform one highly precise, standardized task perfectly, over and over again, whether that was welding a specific seam or installing one segment of those 8 miles of wiring.
They were essentially mass-producing expertise.
Yes, and the plane itself, the final product, was really only one side of this economic war. The P-47 was also an instrument of immense consumption.
It illustrates the impossible economic situation the Germans were in.
They weren't just fighting a plane, they were fighting a logistics machine that seemed to have no limits.
Let's put some numbers on the consumables because this is where the scale just becomes abstract.
It really does.
By mid-1944, the P-47 fleet was firing over 10 million rounds of heavy caliber ammunition per month.
10 million rounds a month. Just for one type of aircraft. Think about the logistical chain behind that single number.
Mining the raw materials, manufacturing the brass casings, the armor-piercing cores.
Packaging the belts, shipping them halfway around the world, getting them to the airfields. It was a constant, monumental effort just to maintain that level of overwhelming firepower.
It shows the P-47 wasn't designed for a surgical strike. It was designed for what you call kinetic saturation.
Exactly. Delivers such a massive volume of fire that destruction of the target is guaranteed.
And then there's the fuel. Modern air warfare is all about high-octane aviation fuel.
And the P-47's engine was very thirsty.
The U.S. had to ship 25 million gallons of high-octane fuel across the Atlantic every single month.
25 million gallons. That's thousands of tanker ships, dedicated naval escorts to protect them, huge storage facilities overseas. It is the industrial equivalent of moving a mountain of liquid every 30 days.
So when that one plane rolled off the line every hour,
there was a trained pilot ready for it, a tanker full of fuel waiting for it, and a mountain of ammunition behind it. The Thunderbolt was the physical manifestation of that entire unstoppable supply chain.
So when the Germans shot down a single P-47, it wasn't a strategic victory.
It was a temporary delay, a nuisance, because they knew the supply chain was already building its replacement, probably several times over. They were fighting a war of attrition on a scale that only an economic superpower could possibly sustain.
And that overwhelming industrial power had a direct and often tragic impact on the human beings flying the planes.
A profoundly devastating impact.
We have to look at the chasm that opened up in pilot training by 1944. It completely changed the game. It stopped being a contest of equals.
And became something much, much more one-sided. The statistics are just. They're sobering. They show what happens when you combine industrial capacity with a real commitment to your human capital.
Let's start with the American standard. A pilot like Lieutenant Eugene Roberts, he would enter combat with over 400 hours of flight time.
400 hours before he ever saw an enemy aircraft.
And what does that 400 hours actually include? It's not just learning to take off and land.
Oh, not at all. It's comprehensive. Instrument flight rules, high-G maneuvering, complex navigation, emergency procedures for every system on the plane, and crucially, intensive gunnery training.
Including deflection shooting.
Which is the key.
Can you explain that? Because it's a concept that's so critical to understanding aerial combat.
Absolutely. If you're flying straight behind a target, aiming is easy. But in a chaotic, high-speed fight, targets are turning. You have to aim ahead of them, leading them to account for the time it takes your bullet to travel.
It's like leading a bird when you're hunting.
Exactly. But in 3 dimensions at hundreds of miles per hour.
Oh.
It requires these instantaneous, complex spatial geometry calculations that are done purely on instinct and practice.
And that's what makes the difference between a near miss and a kill.
It's the only thing that matters. And it takes hundreds of hours of live fire, in-air practice to get right. So when American pilots showed up, they were trained to be incredibly efficient killers.
Now contrast that with the grim reality for the Luftwaffe in late 1944.
It's heartbreaking. Their training schools were being bombed, their experienced instructors were being killed, and they were desperate for replacement pilots.
So they were throwing people into the cockpit with...
What? Sometimes as little as 30 to 50 hours of total flight time? Not 400, 50. Their training was truncated, rushed, focused on just taking off and landing.
Almost no gunnery practice? No instrument training?
Barely any. They had no time to get familiar with their own aircraft under stress, let alone learn how to fight an experienced opponent.
This disparity, it just turns air combat into an execution. It's not about the Zero's agility versus the P-47's speed anymore.
No. It's about highly trained, well-rested, well-protected professionals facing off against desperate, terrified, often teenage novices who had almost zero chance of survival.
And we have that stark, tragic story of Feldwebel Klaus Brettschneider to put a human face on this.
His entire operational flying career consisted of exactly one combat mission.
And according to his own account, that mission lasted a brutal 12 seconds.
12 seconds. From engagement to the end. He described seeing 4 Thunderbolts diving on his green formation. He attempted a basic defensive turn, a maneuver he'd probably only practiced a few times.
And the American pilots.
They were masters of deflection shooting. They were flying a stable gun platform. They ignored his maneuver, opened fire from 500 meters, and let the 850 cals do their work.
In those 12 seconds, his entire formation was just annihilated.
He survived somehow, but his summary of the experience was simply, the sky rained burning aluminum.
That is the defining image, isn't it? Overwhelming, instantaneous destruction, driven by superior training and industrial might.
But the P-47 didn't just inflict physical damage. It created this profound psychological environment of pure terror. Its sound became a weapon.
Let's talk about that sound signature. The guns. The rhythmic, mechanical roar of 8 Browning M2 machine guns firing at once.
It was so distinct, so relentless, that the Germans gave it a nickname.
Roosevelt's piano.
An incredibly apt name. It wasn't the stutter of cannon fire. It was this heavy, calculated, rhythmic drumming. The sound of an incredible volume of kinetic energy being delivered.
To give the listener some context here, 8 synchronized M2s delivered roughly 150 pounds of projectiles per minute.
That's enough firepower to literally cut a heavy bomber in half, let alone a fighter.
But maybe the most terrifying sound was the one that came before the attack.
Donnerschlag.
Thunderstrike. What caused it?
The P-47 had this huge 4-bladed paddle propeller. When it entered that high-speed dive we talked about, the tips of those propeller blades would actually go supersonic.
Creating a shockwave. A literal sonic boom from the propeller.
A tremendous tearing sound in the air. For a German soldier on the ground or a pilot in the air, once you heard Donnerschlag, you knew the monster was on you. There was no maneuvering out of it. It was the sound of the inevitable.
And this constant threat, this unavoidable destruction, it led to an actual diagnosed psychological condition.
JBO fever. JBO being short for jag bomber or fighter bomber.
And it was a real thing.
It was a complete erosion of morale and combat effectiveness. The P-47 was a threat everywhere in the air, on the ground, hitting trains, convoys, anything that moved.
The terror was all-encompassing.
And our sources show that even hardened Battle of Britain veterans pilots who had survived the most intense air combat in history would become physically ill. They'd have panic attacks at the mere mention that P-47s were operating in their sector.
It signifies a complete psychological collapse, a realization that the fight was just fundamentally unwinnable against such an overwhelming, inexhaustible force.
And we can actually trace that realization from their initial laughter to that final psychological terror through their own documents.
The German intelligence files found at Oberursel after the war, they lay out a perfect three-act story of the American industrial victory.
It's a remarkable narrative told through dry official reports. Act 1 is April 1943. The P-47 first appears. The Luftwaffe assessment.
Minimal threat. Large, unmaneuverable. They literally laughed at it.
They completely underestimated the combination of dive speed and sheer toughness.
The laughter stopped by June 1944, Act 2, right after D-Day.
The P-47 proved itself as a ground attack monster. It was relentless and it could soak up incredible amounts of flak and keep fighting.
So the assessment pivoted completely. Dominant fighter bomber. Critical threat.
The reality had set in. And then we get to the final act, March 1945. The German war effort is collapsing. The American industrial engine is at full throttle. The final verdict is rendered.
Best fighter bomber of the war, unsurvivable in direct engagement.
Unsurvivable. That single word from your enemy's own intelligence service is the ultimate testament to the P-47's legacy.
It wasn't just a successful weapon anymore. It was classified as an eradication tool.
And what's so fascinating is that the German system, which was so focused on high-performance, specialized, efficient designs.
The fencer's rapier.
Yes. They were forced to admit that the American design philosophy, the sledgehammer approach of robustness, volume, and pilot protection, was strategically superior for a total war.
It was the right tool for that specific job.
It absolutely was.
Yeah.
We have to admit, the P-47 was not the prettiest plane. It was not the most agile.
But it was perfectly calibrated for America's strategic goals and its incredible industrial strength.
The design was built on three non-negotiable American principles. First, pilot survival. A trained pilot was an invaluable asset. The Jug was built around protecting him.
Second, massive firepower. Don't rely on finesse, rely on overwhelming volume. The 8 M2s ensured that when you hit something, it ceased to exist.
And third, the most important one, ease of production. If you lose one, who cares? The factory line can churn out 10 more to replace it. It made a war of attrition impossible for the Axis to win.
And this all comes together in one of the most powerful quotes in military history. It's at the U.S. Air Force Museum, right next to gun camera footage of a Focke-Wulf 190 just disintegrating.
The quote is from an unnamed German pilot. It sums up that entire journey from arrogance to absolute terror.
He says, "We laughed when we first saw them. We stopped laughing when we realized they didn't need to turn or climb.
They just pointed those guns at you,
Yeah.
and you ceased to exist."
You ceased to exist." That perfectly captures what the P-47 did. It didn't engage the Luftwaffe on the Luftwaffe's terms of agility and finesse.
It just erased them. It
Yeah.
erased them through sheer, overwhelming, industrialized force. It wasn't just a victory. It was an industrial and strategic obliteration. The Thunderbolt didn't just win air superiority. It demonstrated total industrial dominance.
So as we wrap up this deep dive, the ultimate legacy of the P-47, it seems to be the story of a machine that triumphed everywhere, from Europe to the Pacific, because of three things.
Unmatched durability, which saved its pilots. Unparalleled engineering adaptability, which gave us the P-47N and conquered the Pacific.
And above all, the overwhelming industrial might that built over 15,000 of them with staggering speed and precision.
It was the ultimate expression of American manufacturing capacity applied directly to the battlefield.
And that leads us to our final thought for you, the listener, to take away from all this.
The P-47 Thunderbolt is really the purest example of that American sledgehammer approach. It prioritized robustness, protection, and volume. And while we focus on combat, that underlying logic is timeless.
So the question we want to leave you with is this. How much of modern military strategy or even modern commercial competition still relies on that same philosophy? The idea of prioritizing extreme robustness and scalable volume over specialized, maybe more fragile agility.
When you're facing a global attritional competition, is the biggest, simplest, and easiest thing to produce in massive numbers still the most strategically effective tool you can have?
Is the sledgehammer still, at the end of the day, more effective than the rapier? Something to think about.
Keep questioning the industrial assumptions that drive success. Until next time, keep digging deeper.